This is a continuation of the topic. Last time we discussed the mass spectrometer. Today we'll discuss about the structure. The electronic structure means how the electrons are arranged in an atom. In O levels, you used to draw the structure of an atom and showing the electrons in the shells. So the central part, we call that as the nucleus, which contain neutrons and protons. And around the nucleus, electrons are moving. And for first shell, maximum it can adjust 2 electrons. Then we draw the second shell, and maximum it can have 8 electron, and so on. But actually what happened in A levels, you will learn further division. So what happened? These shells are also divided into subshells. Like there is a shell, and shell is further divided into subshell. Just to understand the idea or the concept of a subshell, example, if you have a building, so this building is representing atom. Then this building will have floors, like there is a first floor, a ground floor. Then the first floor, then second, third, fourth, fifth, sixth, and so on. So if you consider like atom is like a building, and this building will have floors. So these floors, you can refer them as a shell. So atom consists of, the building consists of floors. So atom consists of shells. Shells are like floors. And these floors, each floor will have rooms. So as each floor will have rooms, so these rooms are refers to subshell. So atom is there, atom is like a building. The whole atom is like a building. Then atom is having a shells. These shells are like a floor for the building. And each floor will have rooms, and these rooms are like subshell, means the shells further divided into subshell. So in A levels, you will study about the subshells. So principal energy levels are there, like shell 1, 2, 3, 4. So we have a nucleus, then this nucleus surrounded by region or the shells. And these shells, like this one is the first shell, second shell, third shell, fourth shell. So these shells are further divided or split into sub-energy levels or subshells. What are the subshells? The subshell can be S, it can be P, it can be D, or it can be F. So S, P, D, F are actually the subshells. And S subshell maximum it can hold 2 electron, D subshell maximum can hold 6, P subshell maximum can hold 6, D subshell maximum can hold 10, and F subshell maximum can hold 14 electrons. And these subshells are further divided into, these are called orbits or subshell, and they are divided into orbital. And each orbital, like this is further divided. And each orbital can maximum hold 2 electrons in opposite spin. Example, I will give this an example. So example, first shell. First shell only contain s orbital or s subshell, and this s subshell is having only one division, like, so it can hold electron, one of the electron will rotate clockwise, another one will rotate anti-clockwise. But the second shell can have S and can have P. So second shell can have S, can have P. S can maximum hold 2 electrons. And this P is further divided into 3, and each of them can hold 2 electrons. So that's why the total number of electrons which P can hold, that's equal to 6. But P orbital means this part only. So each orbital maximum can hold 2 electrons in opposite spin. Why 2 electrons in opposite spin? Why not the same spin? The reason for that, because electrons are like charges, so like charges repel. So if they have the same spin, they will produce the same magnetic field, so they will repel each other. To overcome this, if one is rotating clockwise, the other one rotate anti-clockwise, so that the electric field or electric field repulsion or electrostatic repulsion will overcome by attraction. So basically what happened, this is actually how the atoms look like or how the atoms appear, that for any atom, we have the nucleus, the central part, which contain neutrons and protons, and it is surrounded by electrons in the shell, K, L, M. So these are actually shells: first shell, second shell, third shell, fourth shell, and fifth shell, and so on. 6 and 7 are also there. But what happened? These shells are further divided into what? These shells are further divided into subshells. So first shell actually contain only one subshell, that is S. The second shell contain two subshells, S and P. And why it can maximum hold 8 electron? Because in S we can have 2 electron, and in P we can have maximum have 6 electron. That's why the total number of electron which can be adjusted in the second shell, that's equal to 2. That's equal to 8. 2 because of S and 6 because of P. So 2 plus 6, that's equal to 8. Maximum number. Is it clear? First, the concept of the shell and subshell. Now, you have to learn how we will write the electronic structure. So you can see here, principal level means this is a shell and this is a subshell. So first shell only have one division, that is S. But the second shell having 2S and 2P. Third shell 3S, 3P, 3D. Fourth shell 4S, 4P, 4D, and 4F. And how the electrons filling up, or how the electrons will fill up. So you have to learn this table. This is easy to remember. Look, you will write 1S. 1S means first shell having S subshell. 2S, 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F. So first what we did, we increased 1 subshell, and then after 4 decrease 1 subshell, so it will be 5s, 5p, 5d, then 6s, 6p, and at the last 7s. So you can see it's easy to remember. This is how we write the electronic configuration now. So to write the electronic configuration, first thing you have to remember this pattern. So it's not difficult to remember. First it is 1s, then 2s, then 2p, then 3s, 3p, 3d. You can see what I did. We are increasing 1 subshell. What are the subshell? We have s subshell, we have p subshell, we have d subshell, and we have f subshell. These are the subshells. So 1s, then 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 6s, 6p, and 7s. So first we increase 1 orbital till 4, and then we decrease 1 orbital. First you will write like this. Then how filling up will occur? So you have to learn this pattern. Make diagonals. Draw these lines as a diagonal. Now what happened? How filling up will occur? So first we'll use 1s. Electron always occupy the lower energy level first. So first it will fill up with 1s, then it will go to 2p, then 2s, then 3p. So 1s, 2s, from 2s it will electron, once 2s is completely filled, then we'll use 2p. If 2p is completely filled, then 3s. If 3s is completely filled, 3p. Then if 3p is completely filled, 4s. When 4s is completely filled, 3d. Then 4p, then 5s, then 4d, then 4p, then 4f, 4d, 6p. So how you'll remember these arrows? It's a simple way to remember. Look, how we'll complete. Draw the arrows, diagonal arrows. So 1 1, first 2 arrow, 1 1 orbital on them. Then 2 2, then 3 3, and at the last one 4. So it's easy to remember these arrows. You have to just complete one arrow. 1 1 orbital on first 2 arrows, then 2 2 orbitals in second and third and fourth, then 3 3 orbitals or orbits, subshells, and then 4 4. So just you have to complete one arrow at 4. Example, if I say how you'll use this idea to draw or to write the electronic structure. Example, if I say write electronic configuration of iron, which is 26. So you want to write electronic structure for iron atom, which is having 26 electrons. Okay, and S can maximum hold 2, P maximum can hold 6, D maximum can hold 10, and F maximum can hold 14. So how to write this? So first we'll write 1s. How many electron this can hold? Maximum it can hold 2. So I wrote 1s, and maximum number of electron which can hold we write as a power. So 1s2 means in the first shell there is a s orbit or subshell, and which can maximum hold 2 electron. Then we complete this. it will move to 2s. So then it will be 2s. How many maximum number of electron s can hold to? So 2. So we'll write 2s2 because we have to complete till 26 electrons. So 2s2. This arrow is complete. Then we'll start with the third arrow. So it started with 2p. So we'll write 2p. How many electron p can maximum hold? It can hold 6 electron. So we write 2p 6. So till now we arrange 10 electrons. Then after 2p it will go to 3s. So this is 3s. How many electron it can arrange? It can arrange maximum 2. So now total is 12 electron we arrange, but we have to arrange till 26. Then this arrow is finished. Then we start with 3p. Maximum it can hold 6. So we are till 18 we finish. But from 3p it will not go to 3d, it will go to 4s because we'll complete one arrow at a time. So it will go to 4s and s will maximum have 2. So 4s 2. So total number of electrons which we arrange 10 here and 10, so 20. Then after 4s is complete, we'll move on to next arrow. So start with 3d. Then 3d maximum how many electrons it can arrange? So maximum d can have 10, but we are not left with 10. How many electron we are left with? We are only left with 6. So that's why it will be 3d 6. So this is the electronic structure of iron. But when we arrange them, we should write them in order. Order means like first shell, then second shell, then third shell, then fourth. This is the filling up is in terms of energy. Like electron always occupy the shell or orbit which is having low energy first. So why the electron first occupy 4s, not 3d? Because the energy of 4s is smaller. So you will just rearrange in order. So 1s, 2. Why we are rearranging? Because you can see here 4s is first and 3d is after. So we rearrange 1s2, 2s2, 2p6, 3s2, 3p6, 3d6 and 4s2. So first we fill up in terms of energy, that electron occupy the low energy first, and then we rearrange this order so that we will know that there's a first shell, then second, then third, and then fourth shell. Is it clear, this electronic structure of example of iron? Then another example, if I say magnesium. So magnesium is 12, magnesium atom is 12 and 24. So I have 12 electrons. So first it will go to 1s, and how many it should be there? Because s maximum can hold 2. So it will be 1s2. Then it will be 2s. How many it can hold maximum? 2. Then it will go to 2p. How many electron maximum? P can maximum have 6. So I wrote 6. So arrange 10. Then from 2p it will go to 3s. 3s maximum can have 2. So this is the electronic structure of magnesium. Is it clear? How to write the electronic structure? So to write this electronic structure, you have to learn this table. Is it clear? Any doubt how to write the electronic structure? So in O levels, you used to write the electronic structure in terms of shells. Like if I say magnesium, Magnesium is 12 and 24. So you have 12 protons, you have 12 neutrons, and you have 12 electrons. So when you adjust, you draw the nucleus, which contain 12 protons and 12 neutrons. And when you show the shells, the first shell, it will have 2. The second shell, it will have 8. And the third shell, it will also have 2. So the arrangement of electron, the first shell can have 2 electrons. The second can have 8, which makes it 10. And the third one is having only 2 electrons. This is a normal structure which you used to draw. But what happened in reality, the shells are actually divided into subshell, and subshells are further divided into orbital. So in terms of structure, like it will be 1s, means first shell contain s orbital, which will have 2 electrons. Then 2s, 2. Second shell will contain s orbital as well. Second shell will contain s orbit or s subshell, which contain 2 electrons. And also the second shell contain p subshell, which contains 6 electrons. And then 3s, it also contains 2 electrons, so that's 3s2. So you can see here, the first shell you will have 2 electrons, the second shell you will have 8 electrons, and the third shell you are also having 2. So it's a similar way, but the thing is, this is more detail, or give a detail that where electrons are present and how many electrons are in each subshell. But the what you learned in O level is just a simple diagram which shows the total number of electron in each shell. Is it clear? Any doubt in this? So use the screen annotation. Now I will give you some questions and you have to use or draw on your screen, and so that I can see at the same time. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 6s, 6p, and the last one is 7s. These are, so we have to complete one arrow at a time. Now if I say write electronic configuration for neon, number 1 is neon, which is 10 and 20. Write the electronic configuration for neon. Use the screen annotation You can use your screen, draw on your screen so that I can also see. To use in screen annotation, you will find an icon look like a pen or a pencil. Just click on that and draw. Just mention like first one I will do for you, then remaining you have to solve so that I can identify that you are doing correctly. So neon, it has 10 electrons because it's an atom. So when I write, so I will write first 1s. I will write here S maximum can hold 2, P maximum can hold 6, D maximum can hold 10, and F maximum can hold 14. So 1s, I will write 2. Then 2s, I will write 2 as well. Then 2p, because I have to arrange 10, 4 are already arranged. So I'm left with 6, and P maximum can hold 6 electrons. So I will write 2p, 6. Is it clear? The first one. The second one I want you to solve, which is about calcium, 20 and 40. Use screen annotation to answer this. You can use screen annotation to draw on my screen. Yes, draw on the screen. One is 2.
And
Yes. You can use the screen annotation to draw. It's okay. Don't worry about how it looks. Just mention what 1s2, 2s2, 2p6. So means 10 electrons are arranged in calcium, but we have to arrange 20. 3s2. Yeah, so 3s2, 3p6. This should be p. Yeah, that's right. This will be 3p6. And then so it is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So you can see we arrange 20 electrons. Then another example, if I want to arrange electrons in chlorine, which is 17 and 35. What will be the electronic structure for chlorine 1735? Yeah, that's right. So it will be 1s2, 2s2, 2p6, 3s2, 3p5. So means we arrange, first it will go to 1s, then 2s, then 2p, then after 2p it will go to 3s, then from 3s it will go to 3p, and from 3p it should be 4s. But because we have to arrange only 17 electrons, that's why we stop till 3p5. Then we can also represent this in terms of orbital or subshells. So example, if I want to represent, say, magnesium or aluminium, in terms of electron is a box model. So if you have aluminium, which is 13 and 27, so if we arrange them, as we know, the electronic structure or electronic configuration, it is 1s, then 2s, 2p, then 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 6s, 6p, and 7s. In terms of arrows, when we represent, filling up. So when I fill this up in terms of electrons, so it will be 1s, 2, then it will be 2s, 2, 2p, 6, then we already arranged 10 electrons, so we are left with 3. But so after 2p, it will go to 3s. So 3s cannot hold 3, it can hold 2, so that's 3s2. And then 3p will have only, it can maximum adjust 6, but it has, we are only left with 1. So this will be 1. This is a normal electronic structure or electronic configuration. But we want to draw in terms of electron in a box model. So what each, because we know that S contain only one orbital which can hold 2 electron, P contain 3 orbitals, each can hold 1, but there are 3 orbitals. D contain 5 orbitals, each can hold 2, each orbital can adjust 2. but total number of orbitals are 5. And the last one, F is there. Maximum divided into 7, and each can hold 2. So maximum F can have 14 electron. Each orbital can have 2. It is divided into 7 parts. D maximum can hold 10 electrons. So orbital is divided into 5. 5 orbitals are there which make D. P is having 3 orbital. So it's divided into 3 parts. So each can hold, maximum P can hold 6 electron and divided into 3 orbitals. So each can have 2. And S maximum can only have 2 electrons, so there is no further division. First electron will occupy the orbital singly, and then they will couple up. First they will occupy singly, and they will couple. So electron in a box model, so 1s will have one box, 2s will have one box, 2p will have 3 boxes, 3s will have one box, and 3p will have 3 boxes. So how electrons are arranged? First, S having 2 electrons, so one will rotate clockwise, another one is anti-clockwise. So how to represent this? If one arrow is up, other arrow should be down. This will also have 2 electrons, so one arrow up, one arrow down. This having 6 electrons, so 1, 2, 3, 4, 5, 6. This is having 2, so 1, 2. This is having only 1. This is called electron in a box model. Is it clear? Like how electrons are actually arranged in the orbital. So this is actually 1s orbital. This one is 2s orbital. This all is 2p. And in this 2p, this is called 2px, 2py, 2pz. And this is 3s orbital. And then this is 3p. And this is called 3px, 3py, and 3pz. A 3-dimension. Any doubt in this? Same way, if you want to arrange, example, we have another element. You can take any element, say nitrogen or oxygen, or take it with nitrogen. Nitrogen is 7 and 14. So when I write electronic structure, electronic configuration, I have to arrange 7 electrons. So it will be 1s2 and 2s. So 1s2 will be there, then 2s2, then it will go to 2p, Maximum p can have 6, but we are not left with 6. We have to arrange only with 7 electrons. So that's why it will be 2p 3. And when we represent electron in a box model, so 1s, 2s, 2p. How the electrons are arranged in this manner? So S having 2, so it 1 up, 1 down. P is having 2, 1 up, 1 down. Sorry, S is having 2, 1 up, 1 down. 1s is having 2, 2s is also having 2. But what about 2p? It's having 3 electrons. So first electron will occupy singly and they rotate in a same direction. If there was another electron, then it will be anti-clockwise. So this is the structure of nitrogen in terms of electron in a box model. Is it clear? So either all the arrows up or all the arrows down. Because what happened, electrons are like charges, so they repel each other. You don't fill up. First, you have to complete the one box. It's not like that first it will complete one orbital and then the third. No, that's wrong. Basically, what happened, so they will occupy singly and they're moving in same spin is there. That's why we are showing with the same arrows. Either all arrows are pointing up or all arrows are pointing down. Because they're having a same spin, that's why we are representing by an arrow.